2/6 families of functions. The main thing to remember here is looking at the parentheses. So when I see the parentheses here, I think about two different things. If it's outside the parentheses, it goes up and down. If it's inside the parentheses, it goes left and right. Always something about parentheses too. It's opposite inside parentheses. So if you're looking outside, plus goes up, minus goes down. But inside, you would think minus would go left, but except minus actually translates right. Problem 1 says, how are the functions y equals x and y equals x minus 2 related? Well, y equals x is going to run right through the origin there and go up 1 over 1, and that's going to be your y equals x. Well, how is y equals x minus 2 related? That's related because where's the negative 2 at? Well, it's outside parentheses, so it's going to go down 2 units. So since it's here at 0, 0, let's go down a little bit to here at 0, negative 2. That's going to be my y-intercept now of that y equals negative x, and the slope's going to be the same. So it should look parallel if I could draw a straight line, which I can't. That's terrible, but it should be parallel to that line anyway. So it moves it down. So how are graphs related? Moves down 2. Problem 3 talks about letting g of x be a reflection of f of x equal 3x plus 3 in the y-axis. What is the function rule for g of x? So if it's a reflection in the y-axis, our g of x is going to actually equal f of negative x. Okay, so what do? Well, I'm going to take negative x and plug it into the regular thing here. So instead of x there, f of negative x is going to equal 3 times negative x plus 3. So g of x is going to equal negative 3x plus 3. So I'm sketching these graphs. Terrible lines. But we have 3x plus 3. 1, 2, 3 is up here. Okay, up 3, 1, 2, 3, over 1, put another dot there. That would be your graph of f of x. G of x is negative 3x plus 3, same y-intercept. Just change colors here. Same y-intercept, nothing different. But now we're going to go down 3, 1, 2, 3, and over. And that would be my reflection on the y-axis. Now this says problem 4, the table represents a function f of x. What is the corresponding g of x values when g of x equals 3 times f of x? Now the important distinction here is 3 is not in the f. I don't really care what the function f of x is. To make g of x, I want to make sure I just take everything in f of x and multiply by 3. So if I'm making a chart of x's and my g of x's, so x negative 5, negative 2, 0, 3, 5. The g of x is going to be 3 times whatever my f of x was there. So 3 times 2, 3 times 2, 3 times negative 3, 3 times 1, and 3 times negative 2. That's going to be what that is. So then I'm going to end up with 6, 6, negative 9, 3, negative 6. That would be my values for g of x. And you can plot this on the graph. Problem 5, the graph of g of x is the graph of f of x equals 4x compressed vertically by a factor of a half and reflected in the y-axis. What is the function rule for g of x? Okay, so in order to compress it by a half, I need to multiply by a half and reflect in the y-axis. I need to flip the x, make the x negative. So my g of x is going to compress f of x by a half first and foremost. So that's going to equal 2x. That's a compression by a half. Okay, to flip to flip it over the y-axis, so what I'm going to end up doing is taking the negative of x, which is going to give me negative 2x. So my g of x equals negative 2x.